Okay, let's have a look at question 1. F of x is x minus 2 times x plus 1. Okay, so cubic part of the graph of f is shown below. So state the coordinates of all axial intercepts of f. You can just read them off from the, factorized form. 3 of them. Okay, find the coordinates of the stationary points of f. So, insert the problem. Add graphs x times x plus 1, I suppose, times x minus 2, if I'm not mistaken. Yep. Hold on a second. Something wrong with my iPad. Let's see, x minus 2. Okay, here we go. Here's the graph. Now we want to find the coordinates of the stationary points. The question didn't say decimal places, so we have to find, the exact values. Now we can use this f1 of x. So we can just do solve button, pair of click bracket, derivative with respect to x, f1 of x equal to 0, comma, y equals to f1 of x, comma x, comma y. So we have 2 points, okay? 2 points. Okay, let G be g of x equals to x minus 2 with the domain R. Find the values of x for which f of x equals to g of x. Second part, write down an expression using definite integrals that gives the area of the regions bounded by f and g. Definite integrals more than 1, okay, and hence find the total area of the region bounded by f and g, correct to 2 decimal places. So for this one, we need exact value. For this one, I suppose we also need the exact value, but this time we need 2 decimal places. Okay, why don't we just say solve f1 of x equals to x minus 2, comma x. All right, 3 points of intersections, and we can also plot this graph. Go back and plot this graph. Here we go. So basically, the required region constitutes 2 parts. We can actually get the bounded area first. Okay, so that is the total bounded area. Three solutions. Well, if we looked at the graph we plotted before, 2 parts, we can say the total area equals to from the smallest x value to the middle x value. Now, the first interval we have f of x, subtract g of x, dx. Add from root 5 minus 1 over 2 to 2. Then g of x minus f of x dx, okay? And this should evaluate to Oh, bear with me. 5.94605. Okay, now last part. H is a function x minus a times x minus b squared. H of x equals to f of x plus k. Okay, find all possible values of a and b. Now we could say x minus a times x minus b squared equals to f of x is just x times x plus 1 times x minus 2 from memory, and you add k. Now we can also use our CAS calculator to, let's try to expand this equation. Okay, so we have a very long equation here. And if we compare both sides carefully, it's like we can collect the like terms and get a correct equation. Actually, equating the coefficients, I would say. Of course, for this thing here, you can also write a normal equal sign because this is like for polynomial equal to each other for all real values of x. And you could also, let's say, sub in a couple of, different values. But this case, we would just do minus a plus 2b equals to minus 1. And 2a times b plus b squared equals to minus 2. We don't need to find the value of k. So I suppose this equation can be optional, but our main target is to find a and b, okay? Okay, so we have two pairs of a, b values. And that's that. Very nice. I would say year 11 math method question. Okay, question 2. The following diagram represents an observation wheel with its center at point P. Passengers are seated in pods, which are carried around as the wheel turns. So if we have a pod here, it's rotating along. Okay, this Ferris wheel. One full rotation every 30 minutes. Lowest point, point A, 15 meters above the ground, radius 60. So it's like 120 meters and 15 meters. The highest H max is 135 meters. Consider the function minus 60 cosine bt plus c for some bc real numbers. It models the height above the ground of a pod originally situated at point A after time t minutes. So t is greater than or equal to 0. Okay, show that b equals to pi over 15 and c equals to 75. So I suppose my period to complete one cycle is 30 minutes, and that's also equal to 2 pi over b. So b equals to 2 pi over 30. So b equals to pi over 15. And the max height equals to c actually plus 60 equals to 135 as reasoned above. So c equals to 135 minus 60. So c equals to 75. Okay, so that's the average height. Average height over at least one period. Now we can just say h of t equals to minus 60 cosine of pi over 15 times t plus 75. And then we want to find the average height of a pod on the wheel as it travels from point A to point B. Keep your answer meters corrected to decimal places. So the wheel moves anti-clockwise with constant speed. This is very important because with constant speed, we can say, okay, equal increment. When t equals to 0, it's at the lowest point here. Well, this is a quarter of a cycle. So that would be 30 divided by 4, which is 7.5 minutes. Okay, so now the average height is just 1 divided by 7.5 minus 0, from 0 to 7.5, ht dt, okay? So we can actually calculate this using the CAS. Why don't we just define the function first? Okay, 36.802813 something. Two decimal places. Right. Find the average rate of change in meters per minute of a height of pod on the wheel as it travels from point A to point B. You can actually calculate this very easily because That's the average rate, okay? After 15 minutes, the wheel stops moving and remains stationary for 5 minutes. After this, it continues moving at double its previous speed for another 7.5 minutes. Okay, the height above the ground of a port that was initially at point A after 10 minutes can be modeled by the piecewise or hybrid function W here. K is greater than 0, M is greater than or equal to 0, and N is all real numbers. So the change of height is like, okay, from lowest to the highest, then flat for 5 minutes, then going down. Okay, now if speed times 2, now I would say, period will be half because period is a period of time, okay? So with the same height or same distance traveled, if your speed is doubled, then the time is halved, okay? And this K value here, okay, I think this should be a continuous graph. So I would say K equals to H of 15, which is 135 meters at the highest distance to the ground. Okay, and the M value. So think about this. Period 1 is 30. Period 2, because the period has been divided by 2. Period 2 is 15. Okay, and it should be 2 pi over B2. Let's say the third part has this form. H3 equals to minus 60 cosine of B2t plus something at 75, okay? It's just a change in the argument part. So B2 is actually 2 pi over 15. And B1 was pi over 15. So M times B1 equals to B2. Therefore, M equals to 2, I suppose. All right. And then we want to find all possible values of N. Okay, so we can carry on our previous analysis with the known K and M value, but we don't know the value of N. We should realize at this T value, the function should be smooth, actually continuous, I would say. So T equals to 20, H of 4T plus N equals to 135, okay? And this N value can be any real number. So we can actually get a general solution, but notice, because the question already used K and N, we cannot use K, we cannot repeat K or N here to represent, let's say, for example, all integers, okay? So this time I'm going to use another letter. The reason why I'm using A is all integers is because we can take all real values, okay? So actually, we can use the graphical analysis to verify what's happening here. So the total period of time covers from 0 to 27.5. So why don't we just use 0 to 30? And the maximum height is 135. So I want to make sure I can span over the maximum height. So let's try 140 here. The first section should be given by h of x because the cast can only accept x. From 0 less than or equal to x less than 15. Okay, that's the first section. Second part is 135. Given that 15 less than or equal to x less than 20, I suppose. Okay, so that's the second part. And the last part. We know this m value is like 5 times 6 times an integer plus 1. So if I choose a equals to 0, for example, I could just get n equals to 5. So let's try h of 2x plus 5 from 20 less than or equal to x less than or equal to 27.5. Okay, so this is one possibility. And if we choose, for example, another m value, let's say if a is 1, then 6 plus 1 is 7, 7 times 5 is 35. Still the same thing. Okay, it works. So how about choosing a equals to -1? That would be minus 25. The period is going to be, okay, 55. Still works. Okay, so that means our general solution here using A is all integer is correct because that will be taken care by the periodicity of the function. The redundant multiple of the period will be eliminated whatsoever. Okay, so that's why it's saying all possible values of n. Okay. Right, and let's see how we go. Sketch the graph of the, okay, perfect. We already sketched the graph. So now I think it begins from 0, 15, ends at 15, 135. 15. This is 135. For 5 minutes. Okay, I think the middle point should be the point of inflection, 7.5, and the middle value is like 75, I suppose. Okay, let's draw a graph like this. Okay, that's one part. And the other part, I think, are at 27.5. It goes back to here. Okay, and 20 plus 27.5 divided by 2, that's like a 23.75. Okay, so 23 0.75, 75, roughly here. And you can see the graph has been, dilated by a factor of half, squeezed in from the y-axis or the vertical axis. Okay, that's how the graph should look like. Yep. Very nice. Okay. Maybe I should have a look at question 3. Consider the function g of x is 2 to the power x plus 5. So this is like a exponential function. The limit while x is approaching to negative infinity of g of x. So this is just 5, okay? This is the horizontal asymptote. Okay, the derivative g dash of x can be expressed in the form g dash of x equals to k times 2 to the power of x. Find the real number k. Well, we know for any other base a, where a is positive but a is not equal to 1 or e, we should have natural log a times a to the power x. So therefore, g dash of x is natural log of 2 times 2 to the power of x, which means your k value is natural log of 2 or log e of 2, okay? All right, let a be a real number. Find in terms of a the equation of the tangent to g at point a, g of a. So just use our CAS calculator, should be very efficient. Y tangent line. Okay, so it's yt of x equals to 2 to the power of a times natural log 2 times x, etc. Okay. So we can just copy the screen. Just give me a second. Cancel, otherwise find the equation of the tangent to g that passes through the origin, correct to 3 decimal places. Well, basically, hence, if it passes through the origin, the y-intercept part is equal to 0. So we can just solve this bit equal to 0 for a. But remember, you have to find a decimal answer. Otherwise, the CAS won't tell you the exact solution. If you want to express the exact solution, you can use some sort of a non-elementary function like Lambert omega function, etc., or product log function. So this is the a value. And also, because you know the y-intercept is going to be 0, you can just ignore the y-intercept part and sub in the given a value here. So it's like 4.254768 times x. So we rounded the gradient to 3 decimal places. But before we get to the final answer, we probably need to retain as many digits as possible in the intermediate working. Okay, so now we are looking at 2 to the power of x minus x squared. Find the coordinates of the point of inflection for h. Correct to 2 decimal places. Actually, I probably need to go back to define my h of x. 2 to the power of x, subtracting x squared. Okay, let's try this one. All right, so we are expecting some sort of changing the concavity in between 1 and 2. Inflection. Here's the point of inflection. We just need 2 decimal places, so 2.06 minus 0.07. Okay. Find the largest interval of x values for which h is strictly decreasing. Give your answer corrected 2 decimal places. So I would like h dash of x less than or equal to 0. And we could include the endpoints as stationary points, okay? Now, it's fine, okay. Minimum is this in here. Maximum is this in here. So it's roughly from 0.48509 to 3.21243, etc. Okay, and apply Newton's method with an initial estimate of x naught to find an approximate x-intercept of h. Write the estimate x1, 2, 3 in the table below. Correct the 3 decimal places. We can actually define, let's call this one iteration x. Iteration Newton in x equals to x minus h of x. Derivative h of x. Okay, so the initial estimate is 0. So we try to get iteration Newton 0, minus 1.442695, etc. And then we do iteration Newton, the previous value, minus 0.897 something. And then we do iteration Newton, previous value, minus 0.773, etc. We just need 3 values here. Fantastic. Okay. For the function h, explain why a solution to the equation natural log 2 times 2 to the power x minus 2x equals to 0 should not be used as an initial estimate x naught in Newton's method. Normally, if this sort of questions is asked, we could guess, we could make a link actually to zero gradient, because firstly, if we look at h of x, it equals to 2 to the power of x minus x squared. Taking the derivative, you actually get a natural log 2 times 2 to the power x minus 2x. When you set that to 0, the iteration formula is xn plus 1 equals to xn minus h of xn divided by h dash xn. Can't be 0, but this equation will give 0 gradient, or give x values corresponding to the 0 gradient, okay? With estimates from natural log 2 times 2 to the power x minus 2x equals to 0, okay? Or we can say this given equation has solutions corresponding to horizontal tangent, which never cross x-axis, something like that. Okay, so probably explain why you need to explain sufficiently, like I mentioned, parallel gradient or zero gradient something. Oh, look, I'm not entirely sure, so just do your best. Okay, there is a positive real number n for which the function f of x equals to nx minus x to the power n has a local minimum on the x-axis. Find this value of n. Let's define this function. Okay, now take the derivative. Right, we want to set this equal to 0. This is an interesting one. Doesn't give us nothing. Okay. Probably we need to do some trial and error. So we know n is positive. Let's try n equals to 1. See how we go. Minus 1. No, it's not a stationary point. Okay. How about n equals to 2? Solve this thing for x. This thing equal to 0 for x when n equals to 2. Okay, you actually get these two values. But would this be on the x-axis? So the smaller value is a local minimum. It doesn't lie on the x-axis. Nope. We have to keep going. Let's try 3. Okay, so now you have 3 points here. We can actually try f of maybe the last one, n equals to 3. Well, it's now a negative value, but it's getting closer to the x-axis. So probably you need to use some sort of slider method to get it closer to this value. Now let's try n1 to the power of x minus x to the power of n1. And then we can try to create a slider for n1. Okay, so if we adjust, we know it's gonna lie between, the n value is gonna be between 2 and 3 because you can see the pattern. It's like so we can try 2.5, etc. But can I adjust settings here? Yep. If we use 0.01, display digit float 4. Okay. So it's roughly 2.7, 2.71, 2.72, 2.73. 2.71 is actually close to E, okay? So we can actually try E to the power of X, subtracting X to the power of E. Okay, looks like we are getting closest to our answer. So n value could be E. Okay, let's delete this one and see how we go. So if we use E, let's say analyze graph minimum. Yep, 2.71828, which is a decimal approximation of E, but we know this is going to be exactly E, E0. So the problem is solved. Okay. Right. Let's have a look at the remaining question. The manufacturer produces tennis balls. The diameter of the tennis balls is a normally distributed random variable d. Mean is 6.7 and the standard deviation is 0.1. Normal 6.7, 0.1 squared, that's the variance. So d greater than 6.8. Probability distribution norm CDF. 6.8 to infinity. 6.7. 0.1. Okay, 0.158655. Okay, so 0.158655, which is 0.1587 to 4 decimal places. Okay, find the minimum diameter of a tennis ball that is larger than 90% of all tennis balls produced. Give your answer in centimeters, correct to 2 decimal places. The middle value or the mean value is 6.7. If we put my required d value here, this is actually less than 90% of all tennis balls. So it's not on the left-hand side. In fact, why don't we just use this bit? Then for this d value is greater than 0.90% of the area. So b equals to inverse norm 0.90, 6.7, 0.1. Okay, let's see how we go. Probability distribution inverse normal 0.9 as by area, 6.7, 0.1. Okay, 6.828. 155. 6.83 centimeters. Okay. Tennis balls are packed and sold in cylindrical containers. A tennis ball can fit through the opening at the top of the container if its diameter is smaller than 6.95 centimeters. If it can fit through the opening at the top, then it's less than. Okay, so probability of D less than 6.95. Negative infinity. Negative infinity to 6.95. 0.993790. Okay. In the random selection of P4 tennis balls, find the probability that at least 3 balls can fit through the opening at the top. So let's call this one tennis ball, fitting tennis ball, fit or does not fit. So we have n equals to 4. The probability is actually 0.993790, etc. So we would like to find the probability t greater or equal to 3, at least 3. So we are finding 3 less than or equal to t less than or equal to 4. So this is a binom CDF using this value. So we can actually copy the previous result and probability distribution binom CDF. Number of tries for probability success is this value here. Lower is 3, upper is 4. Press OK. So we should have 0.999777055. Oh, this is a very large probability, very close to 1. A tennis ball is classed or classified as grade A if its diameter is between 6.54 and 6.86. Otherwise, it is classed as grade B. Given that a tennis ball can fit through the opening at the top of the container, find the probability that it is classed as grade A. Give your answer correct in 4 decimal places. So we need grade A given fit through. So this is basically saying probability between 6.54 less than or equal to D, less than or equal to 6.86 divided by probability of D less than 6.95, okay? So from previous parts, we actually calculated the probability of D less than 6.95. So it's going to be 0.993790, etc. Anyway, I would just bring in all digits. But now I need to figure this out separately. So I think this should be 6.54, 6.86. Okay, 0.8904014. And we divided these two numbers and a round answer to 4 decimal places. So this is my numerator. Just make sure we copy the correct one. So it's the norm CDF here, which is this result here. Copy, divide, paste, Control Enter, 0.895965. Six zero, corrected 4 decimal places. So we must write this 0 as a placeholder, okay? The manufacturer would like to improve processes to ensure that more than 99% of all tennis balls produced are classed as grade A. So we want a new normal distribution. Assume that the mean diameter doesn't change, so it's still 6.7, but the standard deviation is unknown. Now, we know if we say, okay, this is a new normal distribution, D2, between 6.54 and 6.86. For this chunk of the area, we have 99%. So on the two tails, this will be 0.5%. This bit will also be 0.5%. Okay, so we can actually get, for example, if we choose to use the left tail, we just used an area of 0.001 and get the z-score here. Minus 2.575829. Okay, we have a conversion formula, z equals to d minus mu divided by sigma. Actually, if we want the red area to be larger than 99%, we can actually shift the z-score to the left, okay? So we need 6.54 subtracting 6.7 divided by sigma. This is my z-score, must be less than or equal to minus 2.575829, okay? Similarly, you could use 6.86 minus 6.7 divided by sigma. but it has to be greater than 2.575829, which is a symmetrical z-score. Okay, so let's try. Divided by some s less than or equal to this value here for s. So the s, or the sigma, is greater than 0, but less than or equal to, 0.06 something, okay? So sigma, the required standard deviation, sigma max is actually 0.06, okay? So this is the maximal allowable value. Maximum allowable standard deviation, okay? I think that's the intention of the question. Okay. An inspector takes a random sample of 32 tennis balls from the manufacturer and determines a confidence interval for the population proportion, etc. So the confidence interval is this, correct to 4 decimal places. So firstly, we need to find a p hat, which is the middle of the two confidence levels, two confidence boundaries. You should be able to get a 0.84375 something. Okay, C lower, P hat is here, C upper. So this bit is margin of error, that is Z times standard error, P hat 1 minus P hat divided by M value, which is 32, okay? So margin of error is actually 0.9493, subtracting 0.84375 equals to Z times square root. One minus 0.84375 divided by 32. We can actually use this equation to solve for Z. Ah, 1.6444. So if we do a norm CDF here, minus Z to Z, given this Z value, this is correct, 90% confidence interval. Okay, so that is part G. Oh, we still have a couple of parts. Now a tennis coach uses both grade A and grade B balls. The serving speed in meters per second of a grade A ball is continuous random variable V with a probability function here. Okay, we can define this probability density function. Did I have f before? No, I just need to insert another problem. Yep, it's a separate problem now. F of v is assigned to, let me have a look, 1 over 6 pi sine square root of v minus 30 divided by 3. Okay, so we can actually do probability exceeding 50 meters per second, but it's less than or equal to 3 pi squared plus 30. So let's do an integration. 50, 3 pi squared plus 30. F of v. Give your answer correct to 4 decimal places. So, yep, 0.134516. Find the exact mean serving speed. Okay, if I were to find the mean, notice I need to use 30 as a lower bound instead of 50. So expected value of v is 30, 3 pi squared plus 30. Like x, f of x, we have v, f of v, dv. And copy this without retyping everything again. Just change the lower bound to 30. Pi v times f of v. Very nice number, 3 pi squared plus 4. Need brackets here, or if you expand it, that's 3 pi squared plus 12. Okay? The serving speed of a grade B ball is given by another continuous random variable W with a probability density function GW. A transformation maps the graph of F to the graph of G, where GW is A times F of W over B. So we need a dilation factor of B in the horizontal direction. It's from y-axis. And the dilation factor of A from X. Okay. Now the old mean value is 3 pi squared plus 4. New mean equals to 2 pi squared plus 4. So what happens here is the old mean multiplied by 2 over 3. Okay, so that is like a horizontally, before it's this much, after it's this much. So it's dilating the horizontal distance on the function. Therefore, I would say my B value is 2 over 3, okay? Notice that this function is not FB times W. Otherwise, I have to write B equals to 3 over 2, the reciprocal. Okay, now, if I dilated, think about a triangle or actually a rectangle. Previously, this area equals to 1, right? So once I dilated the horizontal values to 2/3 of its original. So this is 1, this is 2/3, right? Then I have to stretch this rectangle in the vertical direction. So this is like 3 over 2, okay? That's why my A value is just 1 over B, which is 3 over 2, okay? Therefore, A equals to 3 over 2, B equals to 2 out of 3, okay? I think this is very similar to the 2021 method exam question. Of course, you could also do, let's say the area after transformation should be 1. So 30 times a b value and the b times that. And you have a times fv of fv divided by b dv. That equals to 1. So you get a times b equals to 1. Okay. And also the mean value, you can just multiply an extra v in front of the dilated function. And that is equal to 2 bracket pi squared plus 4. Okay, so you have this sort of equation, and then you just solve simultaneously. So basically you get a equals to 3 over 2 and b equals to 2 over 3. Nice numbers. Maybe I should take a screenshot here for future reference. Okay. Just leave it here. All right. And is there anything else? Oh, I forgot. Nearly forgot. There is a last question. Question 5. So let f be f of x equals to e to the power x plus e to the power minus x. Is that Cauchy or Sanch? I couldn't remember. But anyway, we need to define functions through another function. Okay, complete a sequence of transformations. So this can be written as half f of minus x minus 2 for the Doctor T order. Dilation factor half from the x-axis. Yep. And the reflection in y-axis. And translation by 2 units to the right. So it's like half of f of x, half f of minus x, and half of f minus, in the bracket, x minus 2, close bracket. Okay, follow that order. Of course, you could also do something like, you can also translate to the left by 2 units and then do the reflection, but the order does matter. Okay. All right. And then we need to look at G. Okay. So let's define this one. Okay. Define f of x equals to exponential of x plus exponential of minus x. If I'm not mistaken, is that correct? Yep. Define g of x equals to half times f of 2 minus x. Okay, that's another. Now if we plot the graph of g of x. Okay, so this graph has a local minimum at 2, 1. Okay. So basically, with reference to the graph, we can have a further examination on that. We have 2 functions created with the same root but with distinct domains such that G1 is strictly increasing. So this is G1 and G2 is strictly decreasing. Okay, so the domain, actually it's the maximal domain. domain of G1x equals to 2 to infinity for strictly increasing, and the range of G1 of x equals to 1 to infinity. The question says the domain and the range for the inverse of G1. So swap x and y for G1 inverse. It gives me okay, so I think I will need to identify this very clearly, okay? Read the question is very important. Okay. Shown below is the graph of G, the inverses of G1 and G2, and the line y equals to x. The intersection points between the graphs of y equals to x, y equals to gx, and the inverses of G1 and G2 are labeled as P and Q. Find the coordinates of P and Q corrected to decimal places, and find the area of the region bounded by the graph of G, inverse of G1, and the inverse of G2. Okay, so let's actually plot y equals to x here. And if we need some sort of a graphical representation, we can actually change the graph entry to relation. And we write x equals to g of y. And then we can change the color. We can change the color later, but you can see it's actually a bounded area symmetrical about y equals to x. So graph entry, change back to function. And then we analyze the graph intersection between the line and the original function. Analyze graph, intersection, line, g of x. Okay, so we have two coordinates. Let's write them as P is at 1.2747, which is 1.27, 1.27. And the Q is going to be 4.09, 4.09. And to find the area of the region, actually, I probably will mention XP equals to 1.27, 4736, etc. And this is XQ equals to 4.085, 186, etc. Okay, and if we want to find the total bounded area, we can just figure out half of it and double it up. So the area equals to 2 lots of 1.2747, 36, etc. Nothing harmful to keep more decimal places. 4.0852. Actually, 186, not 2. X subtracting g of x. Perfectly upper minus lower. And let's see. Okay, so the answer is like 5.56 square units. Okay, I can just verify this using my graphs. Analyze graph, bounded area, this graph and this graph from. Okay, yep. So basically we are just doubling this up, 2.78045 times 2. Okay, so we get a 5.56 something. Very good. Okay, let h be 1 over k fk minus x, where k is positive. K is a positive real constant. The turning point of h always lie on the graph of the function y equals to 2x to the power n, where n is an integer. Find the value of n. So, define h of x. H of x equals to 1 over k times f of k minus x. What's going wrong with the entries? All right, so we say the turning point is along y equals to 2x to the power n. Can actually, firstly, we find the location of the stationary point. H of x equals to 0 for x. So x equals to k is not equal to 0. And then, because when x equals to k, we can say h of k gives the y value, but the y value is also equal to 2 to the power x to the power n. So 2 to the power k to the power n. And we want to solve for the value of n. All right. Basically, it gives you n equals to natural log 1 over k divided by natural log k. But this is not yet simplified. So if we press Control Enter, doesn't work, but how about we just extract this equation itself? So have 2 over k equals to 2 times k to the power n, which is n equals to minus 1. It's the reciprocal, okay? So we say h dash of x equals to 0 gives you x equals to k. Then h of k equals to 2k to the power n. That gives you 2 over k equals to 2k to the power n. So n equals to minus 1. And that is the answer intended, I suppose. All right. And let h1 be restricted from k to infinity. And h1 of x is equal to h of x. The rule for the inverse of h1 is this guy here. And we'd like to find the smallest value of k such that h will intersect with the inverse of h1. Give your answer corrected to decimal places. So we can actually slider this one. Use slider. All right, let's give it a go. Let's give it a go. H of x in terms of k is like this thing here. How about I make this one k equals to k1? Okay. Now I can copy this, create a new page, and pasting something in terms of k1. So this is to avoid variable clashes. Create a slider for k1. Yep, that's fine. And also, we probably want to involve x is greater than or equal to k1. Okay, so we only have this branch, the right-hand side branch. Now we can just look at the given equation because we didn't need to find the equation. Oh, that was lovely. Natural log of k1 times x divided by 2. Add 1/2 square root of k1 squared times x squared minus 4 plus k1. Okay, perfect. This is like this is like the inverse function with a varying parameter k1. Now, because k value needs to be corrected 2 decimal places, I would suggest go to settings and change the step size to 0.01 at least. Okay, so we can start to drag. So we can see it's roughly 1.27. Okay, 1.27. Okay, it is possible for the graphs of h and the inverse h1 to intersect twice. This occurs when k equals to 5. Find the area of the region bounded by the graph of h and the inverse of h1 when k equals to 5. The graphs of h and the inverse of h1. Okay. So let's try. The graph of h does not have the restriction. It's negative infinity to infinity. So I probably will look at this thing, copy, and then go back to the previous one. I will swap F3 with that. Okay, let's drag it to there. K1 equals to 5. Zoom out. Analyze graph, bounded area from the first intersection to the second intersection. Oh, nice. We found the area, and then we can just do analyze graph, intersection, 1.4509 something, analyze graph, intersection, 8.78157 something. Okay, perfect. I should have put a -1 here. H1 inverse of x is the upper function, subtracting h of x dx. That gives you 43.9139, etc. So corrected 2 decimal places, that's 43.91 square units. Okay, finally it's done. Well, took me slightly longer than expected. So if I were one of the VCE students this afternoon, I probably won't be able to finish the paper within the time constraint. Well, maybe not. But anyway, this is just my historical recording for my future teaching and learning. Okay, that's it. Best of luck and see you all in the near future. Bye bye.